Welcome to video 7.1 on the element dot notation. This video is going to help you understand how to draw basic Lewis dot structures for atoms and then explain the symbolism behind that Lewis dot structure. When we get started, we have one vocab term called the Lewis structure, and you're going to need your notes and your periodic table. So grab a pencil as well, and here we get going with Lewis dot structures. So a Lewis structure is a visual way to look at an atom or a molecule. Here you can see that we have the symbols, the chemical symbols being represented still in this structure. And we're also using lines and dots to represent electrons. More specifically, these lines are representing electrons that are in a bond, in a chemical bond, and these dots are representing electrons that are in an electron pair. So these are all valence electrons, as I'll show you in a second, but these dots represent electron pairs, and these lines represent a chemical bond, with this being a single bond, this being a single bond, and this being a double bond. Each single chemical bond has 2 electrons, and every double bond has 4 electrons. So you can see each line represents 2 electrons, and each dot represents 1 electron. So this video specifically, we're going to deal with Lewis structures for individual elements. Your next video, I will show you how to draw things like this, where it's a compound or a molecule getting written in a Lewis dot structure. So a Lewis dot structure for an atom is relatively easy. The key here is being able to count up the valence electrons off your periodic table and then simply just put dots around the chemical symbol. So for an atom, these dots are representing the valence electrons on an element. So when I look at my periodic table here, let's remind ourselves of how to find valence electrons. All of these guys in group 1 have 1 valence electron because in their outer shell, there's just 1 electron. In group 2, these guys all have 2 valence electrons. Remember, we can look here at the electron configuration, and it's all the S and P electrons in the highest energy level. When we look at boron, these guys all have 3 valence electrons. Carbon all has 4 valence electrons. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. Fluorine has 7 valence electrons. And finally, helium has 2 valence electrons, but neon below all have 8 valence electrons. So as we get going here, we see that we're just going to write down the chemical symbol, and then we're going to add the valence electrons by representing it by a dot. And we're just going to put them on the side and move around clockwise. You can consider this like the compass points, north, east, west, and south. We're just going to pick a spot and start putting dots around the element. Now, one key thing you'll see here is that when we go to add 5 or more dots, we want to double them up. So here with 1 dot, it's simply by itself. Here with 5 dots, though, we're going to start doubling up the 5th and here even the 6th electron. These are really, really quite easy. I'll show you one, but then you need to practice these on your own. So let me show you how to do the first one, and then pause the video and you try a few by yourself. So here we go. Draw out the Lewis structure for hydrogen. Step 1, simply write down the chemical symbol. Hydrogen, hydrogen. Determine the valence electrons. He has 1 valence electron because he has only 1 electron in the s orbital in the highest energy level, and we just simply put a dot. You could put that to the side, the top, I don't care, but you just need hydrogen with 1 dot. Pause the video, try the other ones, and if at any time you want to pause the video, watch me show you another one, that's fine, but you really need to start trying these yourself. They're that easy. Okay, let's do fluorine. Fluorine is an F. We see fluorine has 7 valence electrons because he has 1, 2, 3, 4, 5, 6, 7. Or I could look here and it says 2s2, 2p5. So the S is 2 electrons, the P has 5 electrons. That's a total of 7. So I just pick a spot, start going clockwise around, adding dots. So there's 1 electron, 2 electron, 3, 4. Now my 5th electron, I need to start doubling up. 5, 6, and 7. So what we are seeing here is we are seeing that this 7th electron is actually unpaired. And we're going to use this to begin to explain and understand how chemical bonding will occur. Based on the octet rule in the next video, you're going to see that fluorine is going to look for an electron. That's why fluorine, to obey the octet rule, will either steal electron or will bond with stuff to get that 8 electron to obey the octet rule. But this is just a visual way for us to help interpret the octet rule. Sulfur, we'll do that one real quick. Sulfur, again, he has 6 valence electrons. 1, 2, 3, 4, 5, 6. Phosphorus, look at phosphorus. He has 5 valence electrons. 1, 2, 3, 4, 5. So these are your Lewis dot structures for individual elements. So long story short, these Lewis structures just represent the structure of an atom or a molecule. We use the chemical symbols to represent the elements, and the dots represent the electrons. In a minute, your next video will add lines, which will show electron pairs that are in a bond. But all this is doing is giving us a visual representation of the valence electrons so that we can better interpret and apply the octet rule and better understand and predict the bonding in chemical compounds. Have a great day.